So now we're going to get into part 2 of section 2.1, which is all about, again, angles and trigonometry. We're going to talk today about special right triangles. Now, the special triangles that we know are some of those common angles that you deal with all the time. So we're talking about angles of 30 degrees, 45 degrees, and 60 degrees, because these are the most common reference angles that you're going to have. With these special angles, you can determine the exact values, which means there's no decimals included. You can find the exact values of the trig ratios. And when I say trig ratios, I mean sine, cos, and tan. So this is where we're going to now start associating these triangles and angles with sine, cos, and tan. So let's talk about the first special triangle that we have. If you started with a square, and the square had side lengths of 1, and then you took that square and you sliced it down the middle, we'd get a right triangle with side lengths of 1 and 1. Now we can find the missing hypotenuse by going a squared plus b squared equals c squared. So 1 squared plus 1 squared equals c squared, which means I get 1 plus 1, so 2 equals c squared, and then when I square root it, I get square root of 2. So that means in a 45, 45, 90 triangle, because these would be 45 degrees each and 90 degrees, okay, in a 45, 45, 90 triangle, my side lengths are 1, 1, and square root 2. Now, since this is a right triangle, we could find sine, cos, and tan. We know that sine is opposite over hypotenuse. We know that cos is adjacent over hypotenuse. And we know that tan is opposite over adjacent. Just SOHCAHTOA from grade 10. So now let's find sine 45 degrees. So if I think about this 45 degree angle, the opposite would be 1 and the hypotenuse would be root 2. Now the issue here is that we can't have a root in the denominator. Remember, you have to rationalize this just like we've been doing. So I'm going to multiply both top and bottom by root 2. So my actual answer here is 1 times root 2, so root 2, and root 2 times root 2 is root 4, which reduces to 2. So sine 45 is actually root 2 over 2. Cos 45, we're going to do the same thing. Adjacent is 1, hypotenuse is root 2, and when I multiply out by that root 2 over 2, we get the exact same thing as sine, which is root 2 over 2. And that should make sense because both the opposite and adjacent were the same. Then we go to tan. Tan is opposite, which is 1, over adjacent, which is 1. So tan 45 just has a value of 1. So this, again, is our special right triangle, 45, 45, 90. And the ratio is 1, 1, root 2. Now the other right triangle is called a 30, 60, 90 triangle. And how we came up with that is we started with an equilateral triangle where all the side lengths were 2. Then we took that and we cut it in half and made a height. So whenever you make a height, that's going to form a 90 degree right angle. So then what we have again is this side is 2, but since I cut this in half, now this side is only 1. And again, if I go a squared plus b squared equals c squared, the hypotenuse is 2, so 2 squared equals 1 squared, let's say, plus b squared. So we get 4 equals 1 plus b squared, and then if I move that 1 to the other side, we get 3 equals b squared, so the square root of 3 is b. So this side length would be the square root of 3. And so this triangle that we're talking about is our 30, 60, 90. Remember that side lengths, small side lengths are across from small angles. So that means that this side length here would be the 30, and this side length here would be the 60. Now let's use what we know there. So again, we said that this is root 3. Let's use what we know here to find sine of 60. So sine is opposite over hypotenuse, which is going to be root 3 over 2. Let's find cos of 60. Cos is adjacent over hypotenuse, so 1 over 2. Tan of 60 is opposite over adjacent, which is going to be root 3 over 1. Now we're going to start looking at the 30 degree angle. So we're going to look up here. Opposite of 30 is 1, so 1 over 2 is sine. Adjacent of 30 degrees is root 3, so root 3 over 2 is cos 30. And then tan is opposite, which is 1 over adjacent, which is root 3. Now remember that we can't have that root in the denominator, so I'm going to multiply it out to rationalize it, leaving me with root 3 over 3. Root 3 over 3. So those would be the sine, cos, and tan values for 30 degrees and 60 degrees. And remember again that this special triangle is called 30, 60, 90, and the side lengths are 1, 2, and square root 3. Let's look at one more example. This would be an application example. So Allie's learning to play the piano. Her teacher uses a metronome to help her keep time. The pendulum arm of the metronome is 10 centimeters long, so this length here is 10 centimeters long. And it moves from a starting position of 60 degrees to an ending position of 120 degrees. We want to find what horizontal distance the metronome travels in one beat. So I'm looking to see how far it travels from basically here to here. Okay, so I'm looking for this x value, and I'll have to multiply it by 2 because technically that would move over here to be this x value as well. So let's think of this as a right triangle. I know the hypotenuse is 10. I don't know the x-axis, which in this case would be the adjacent, but I know that I have a 60-degree angle. So if I think about SOHCAHTOA, adjacent and hypotenuse is cosine. So I'm going to do cos of 60 degrees equals adjacent, which I'm calling x, and hypotenuse, which I'm calling 10. Now we have to keep this all exact, which means you have to think about your special triangles to figure this out. So cos 60, we said before, is half. So I'm going to plug in half instead of cos 60 because cos 60 equals half. And now I just have this proportion that I can cross multiply out. So I'll multiply out the 10 and divide out the 2. So I get 10 equals 2x, divide out the 2, so x equals 5. So that means that this adjacent portion is 5 centimeters. But I don't just want that, I want the whole horizontal distance. I need this whole thing. So I actually have to go 5 plus another 5. So the total would be 10 centimeters that the metronome travels horizontally. Now again, please take a few minutes to think more about these special triangles. It is a great idea to memorize them, the 1, 1 square root 2 triangle and the 1, 2 square root 3 triangle for your future math. And here are your textbook questions for today. Have a great day.